In this video, we'll quickly look at the boxcox transformation. So we're looking at our bike rental database, and then we have our response variable, which is day schedule. And looking at this variable, we would like to understand, whether something could be done to this so that it can look or resemble like a normal distribution. So that's the basic application of boxcox transformation. So I could typically, start with a histogram. And histogram will tell me that this is a right skewed distribution. And if I have to plot this compared to the normal distribution, I can quickly do a QQ norm plot. And I can see that it is not a straight line, right? It is matching between -1 to 1 as far as the theoretical quantiles are concerned. But then it is rising way up on the right side. That's why it's a right skewed distribution. So boxcox transformation is about finding some coefficient called lambda, which a response variable can be raised to as power function and divided by the same constant. And the hope is that it would somewhat resemble a normal distribution. So that's the basic concept behind boxcox transformation. So there's a function called boxcox in R, and we'll quickly run that to get the lambda value. So what it does is basically it plots a constant which is lambda, and that constant is found based on maximizing the log likelihood function. So in this case, you can see that the plot tells me that it's somewhere between 0 and 1, closer to 0. And to find the exact value, I'll have to back calculate the index, which I just did now through the index functions, and then I can quickly look at the value of lambda as 0.2. So that means if I have to raise the response variable, which is the casual biker count, and what I'm going to do is have to raise that each value by 0.2. That means I have to raise it to the power of 0.2, and then I have to subtract 1, and then the result will be divided by the lambda constant again. So it's y raised to lambda minus 1 upon lambda. So that's the transformation, and I can quickly do that here. So I'm raising the casual count to the power of lambda, subtracting 1, and then dividing by lambda, and we'll quickly take a look at how the value looks like. So you can see that as our count, original count is 331, 131, 150, and so on, and our transform count is 10, 8, 8, 7. So it's not only reduced in volume, but it is also, hopefully it will resemble a normal distribution. We'll find out. So this is how a normal QQ plot looks like, and you can see that most of the points are now lying on the line which basically identifies a normal distribution, right? So most of the sample quantiles are now matching with the theoretical quantiles, with the exception of few outliers. So that's roughly the concept of boxcox.